Welcome to AI Frontiers, the podcast where we explore the latest breakthroughs in computer science and artificial intelligence. Today's episode focuses on the frontiers of robotics, synthesizing 3 papers published on May 23, 2025. We'll delve into recent advancements in human-robot interaction, perception, and learning, while highlighting transformative technologies and methodologies that are shaping the future of this dynamic field. In today's episode, we'll provide an overview of the robotics field and its multidisciplinary nature. Robotics combines elements of artificial intelligence, control systems, sensor technology, and mechanical design to create machines capable of operating autonomously or semi-autonomously. Key themes include human-robot interaction, perception and planning, and collaborative systems. We'll also examine groundbreaking findings and methodologies that are driving innovation, with a closer look at 3 seminal studies leading the way. The field of robotics integrates artificial intelligence, control systems, sensors, and mechanical design to create machines that can perceive their environment, make decisions, and perform physical actions. Robots have transitioned from structured environments like manufacturing floors to more dynamic and unpredictable settings, including healthcare, space exploration, and everyday household assistance. This evolution reflects a shift from pre-programmed sequences of actions to adaptive decision-making, enabling robots to think and act independently. A major focus in robotics research is enhancing human-robot interaction through natural and intuitive mechanisms. For instance, Wang et al. Developed a bio-mimetic model for reflex responses, replicating biological mechanisms in robotic systems. Proprioceptive signals in soft anthropomorphic hands improve adaptability, enabling applications in rehabilitation and assistive technologies. These advancements aim to create robots that interact seamlessly with humans and their surroundings. Another key theme in robotics is improving perception and planning capabilities. Studies have achieved significant progress in areas such as high-speed obstacle avoidance for drones, which demonstrates 94.34% accuracy. Single-view mesh reconstruction supports digital twin environments, while cooperative manipulation enhances human-robot teamwork. These innovations enable robots to navigate complex environments and perform tasks with greater precision and efficiency. Learning and adaptation represent a third critical area in robotics research. Neves et al. Compared LSTM, Transformer, and LSTM models for classifying long assembly tasks, demonstrating the potential of hierarchical data collection for teaching robots complex tasks. Reinforcement learning techniques have also enabled safer trajectory planning, allowing robots to learn optimal behaviors while adhering to safety constraints and operational guidelines. Recent robotics research has yielded several key findings. ExoGait-MS achieves 94.34% accuracy in personalized gait recognition, marking a breakthrough in exoskeleton technology. High-speed obstacle avoidance systems reduce processing time by 79.24%, enabling drones to operate at speeds of up to 15 meters per second in cluttered environments. Plan R1 enhances safety in autonomous vehicle trajectory planning, incorporating explicit principles like comfort and traffic rule compliance. Methodological innovations in robotics research include the dominance of deep learning architectures such as convolutional neural networks and transformers. Reinforcement learning techniques incorporate domain-specific constraints, while physics-informed models combine neural networks with physical laws. Hybrid systems enable more robust real-world applications, bridging the gap between theoretical models and practical implementation. Liu et al. Introduced ExoGait-MS, a groundbreaking approach to personalized exoskeleton control. By combining graph convolutional networks with gait dynamics learning, they achieved 94.34% accuracy in recognizing individual walking patterns. This advancement holds significant implications for rehabilitation medicine, enabling exoskeletons to provide tailored assistance based on each user's unique physiology. Neves et al. Conducted a comparative analysis of LSTM, Transformer, and LSTM models for classifying long assembly tasks in collaborative robotics. Their research demonstrated that LSTM achieves superior cross-operator performance at 60.8%, compared to just 43.5% for LSTM. This finding advances collaborative robotics in industrial settings, highlighting the importance of generalization across multiple users. Wang et al. Created a bio-mimetic model for heat-evoked nociceptive withdrawal reflexes in upper limbs. Using spiking neural networks trained with bio-plausible mechanisms, they successfully replicated human-like spatial and temporal responses. This work has potential applications in prosthetics and assistive devices, offering new possibilities for enhancing human-robot interaction. Looking ahead, several challenges and opportunities remain in robotics research. Bridging the gap between controlled laboratory environments and real-world applications is a persistent obstacle. Integrating multimodal sensing capabilities could enhance environmental awareness, while improvements in energy efficiency are crucial for sustainable operation. Developing standardized evaluation protocols will facilitate benchmarking and accelerate progress in the field. This synthesis was created using GPT, qwen-max, and Stable Diffusion, with TTS synthesis powered by Google text-to-speech technology. While the content has been reviewed by human experts, it may contain oversights. References are provided for all cited papers, ensuring transparency and accuracy in our presentation of the research. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archived preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.